Question on annihilation. So I've split this up into three different parts. First of all, what is annihilation? So here an electron is meeting with a positron, its antiparticle. So when a particle meets its antiparticle, the collision is called an annihilation reaction. And what happens is they produce two photons which move off in opposite directions. Why do they move off in opposite directions? Well, it's to conserve momentum and energy. Now, it's asking us to find the wavelength of each of these photons. How do we find that? Well, we're going to combine these two equations actually. That's where wavelength is introduced. Replacing frequency with speed over wavelength, we have energy equals h multiplied by speed over wavelength. Now, h is a constant, Planck's constant, which is given to you in an exam. C, well, because we're talking about a photon, we know it travels at the speed of light, which is 3 times 10 to the power of 8. Now the wavelength is what we're trying to find, and we can make it the subject of the equation by simply just replacing the positions of energy and wavelength. And we can just say that wavelength is hc over energy. But what's the energy of each of these photons? Well, all of this energy comes from the rest energy of the electron. So what we do is we take the rest energy of an electron, which it will be given in an exam. I've just written out here. And before we use that in calculation, actually, we have to convert that into joules. How do we do that? Well, to go from mega electron volts to electron volts, you multiply by 1,000,000 or 10 to the power of 6. And then to go from electron volts to joules, you multiply by 1.6 times 10 to the minus 19. So in total, you're multiplying by 10 to the 6 and 1.6 times 10 to the minus 19. But combining these powers together, using what we know about indices, we add the powers. 6 take away 19 is minus 13. So you're essentially multiplying by 1.6 times 10 to the minus 13. So that's what we're going to do to this value of mega electron volts to convert into joules. Let's put it all into calculation now. So the wavelength is Planck's constant, which I mentioned is given in an exam. I'm just going to write out here 6.63 times 10 to the power of minus 34, multiplied by the speed of each photon, which I told you it travels at the speed of light, divided by the energy that each photon has. So one of the electrons will transfer all of its energy to one photon, and the antiparticle will transfer all of its energy to the other photon. And here it's only asking for the energy of each photon, sorry, wavelength of each photon. So we only need to take the energy of one of the particles in the collision. So we take 0.511 and we multiply by what we need to multiply by to convert it into joules, 1.6 times 10 to the minus 13. You can put all of that into a calculator. If you'd like to break it down into more steps, you can, but you won't get more marks for doing that. And your final answer is 2.43 multiplied by 10 to the power of minus 12 meters. It's meters because wavelength is a distance, so it's measured in meters. Hopefully that made sense. Please like the video, comment, subscribe, and I've linked my email in the description if you have any tutoring inquiries. Thanks for watching.